Hello. Today I will be showing you my custom data structure, the buff table. Using this data structure, I will show how games implement stat buffs or debuffs. To start, let me talk about what I mean by a temporary stat buff. A temporary stat buff or debuff is an increase or decrease to an object's individual values and attributes that is usually modified based on a percentage multiplier. Temporary buffs are temporary, meaning they have durations and a time limit before you have to reapply. Some good examples I was able to come up with is the gold foul foot consumable item from Elden Ring, which buffs the character's rune gain for about 5 minutes. The rune giant from Clash Royale, where the card gives 2 nearby units a flat damage buff at every 3 hits. Moves like Swords Dance from Pokemon, which buffs a Pokemon's next attack. And of course, Minecraft potions. All of these examples I have mentioned have similar attributes. They all have a stat type, multiplier, duration, and a name. For those who live under a rock, here's a diagram to represent what I am talking about. We have Henlo and Benlo who have the exact same stats. Henlo uses the attack buff move, which increases his attack by 50%, or a multiplier of 0.5. After applying this attack buff, Henlo's attack is now 30. He then uses a slash attack and deals 30 damage. If he wasn't buffed, he would only do 20 damage. Once the duration of Henlo's buff runs out, his attack goes back to his base of 20. Now time for some fun math. Whenever we talk
about percentages, we are referring to a fraction over 100. Now if we take that decimal, actually I think you guys already know this stuff. Why the heck should I explain this in the script when I could just use a whiteboard? I bet you all won't notice me saying this at 2 times the speed, but anyways, I could just keep yapping and yapping, so that's what I'm gonna do. Yap 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 yap.
Something. Oh, we're done. Okay. I hope my explanation explained the math behind multiplier calculation. From this project, I hope to make my life easy when I calculate things in games. Here is my purpose for the program. I will be using VS Code as my text editor, as well as the Java virtual machine. For my data structures, I am using hash maps, linked lists, and iterators. I assume most of my audience are not computer science people. So, I will provide basic explanations of these data structures. Like the video and subscribe, and I will maybe do an explanation of all data structures video. Let's start with one of the greatest data structures, hash maps. There is a saying in the computer science world that if you don't know what to do, throw a hash map at the problem, and it will always work. Hash maps are great as they are easy to use and efficient. The hash map runs at the legendary fast run speed of O of 1. Unlike arrays, this data structure reads a key object to obtain a stored value. Hash maps utilize hashing to convert a key object into hash code using a hash function. This hash code is then modded by the length of the table to obtain an index. Of course, the hash function is not perfect and collisions are prone to happen. Collision occurs when 2 hash codes of 2 different key objects point to the same index. To combat this, we use probing. I believe that the hash map uses linear probing, where the algorithm checks for the next available spot on the table. At worst case, the hash map placing an object is O of n, or linear time. Here is a representation of a hash map. We have the keys, Henlo, Benlo, Renlo, Lenlo, and backwards Henlo. Of course, the hash function finds the proper indexes for the first 4 names. However, for backwards Henlo, a collision occurs. In that case we use linear probing to find the next available index. In this case, index 4. Next is the linked list data structure. Linked lists are built using a smaller data structure called a pointer, or what I like to call a node. This data structure stores a generic data type, which could be literally anything, and another node, in which we call the next data. Unlike arrays, linked lists don't have a limit to size, making this data structure perfect when we don't know how many things we are going to put in this list. Still confused? Here's a demonstration. In this diagram, the ovals which represent data have pointers to another oval that stores different data. Whenever we call next, we get the data of the next oval as well as the next pointer. This all brings me to iterators, where we can traverse through a linked list and even a hash map. The next method obtains the next object stored, and the hasNext method checks if there are any more items in the data structure. Of course, we mainly use this in a while loop, where our condition is the hasNext method. Here's a diagram representing what I am talking about. I am traversing through a linked list, with data, henlo, benlo, and renlo. If I call hasNext, the conditional method returns true. We will then go to the next object. And now we start at henlo. We call it next, and the condition is true. We went to benlo. This process repeats until the next pointer is null. Once null, the loop ends. This process is the same for hash maps. However, hash maps have two iterators. One for the key set and one for the value set. We will use the iterator for keys for this project. Here is my UML for my buff table. To explain, my data structure stores a hash table that reads a string and returns a linked list of buffs. Buffs is an inner class method in my BuffTable Java project. Buffs stores a name, a duration, and a multiplier, in which we can directly call these variables due to it being an inner class. The constructor initializes the hash table. Now, let's explain my methods in my BuffTable. The addBuffType method adds a new buff category. We can add individual buffs to that category using addNewBuff. We can use contains_buff, getBuffIndex, and buffFrequency to check if a buff exists in a category in the buff table. To get the total multiplier of the buffs, we use the getCategoryMultiplier method. Of course, we can modify our buff durations using these methods here. Lastly, here is my plan. Let's go to VS Code. Here is my code for the buff table with attributes and constructor, not really anything too special. Here is the code for adding buffs and buff categories. Again, fairly simple code. Here are my buff checking methods. These methods are a bit more complex, utilizing iteration. Thus, these methods run on O event time on average. In the best case, O of 1. Overall, for these methods, I literally copied and pasted. This is my getCategoryMultiplier method. The user puts a category in, and the program does the math I did earlier. Lastly, we have our edit methods. We use these methods to modify the durations of the buffs. Of course, we have a debug method, that being display buffs. Now, here is my test code. I have created a class object named fighting character. This class simply stores health, attack, and of course the buff table. I have initialized health and attack buffs to the table, as well as modified the getAttack and getHP methods. Now, let's test our program.
Insane